Hello everyone, today we'll talk about the solution to the problem convert 1D array into 2D array. This is a simple implementation problem, implementing a very useful and common operation. Well, what we have to do here is to convert a 1D array into a 2D array, but more generally we want to think about what the coordinate conversion is, from one-dimensional coordinates to two-dimensional coordinates and back. So the basic idea is that if you have some two-dimensional array, it has some width, it has some height, then here you have numbers from 1 to width minus 1. Here from width to width minus 1, and so on. So it means that when you have in a given row your elements, then they have consecutive numbers. If you want to go some number of rows down, you have to add width to your numbers. So in particular, at a given position, you have the row number times the width, which in this case is n, plus the column number. And this is the standard normal coordinate conversion between 1D and 2D coordinates. In some cases it's useful to do it even if you don't really want to think about 1D or 2D arrays. So for instance, if you're given a 2D array, it might be easier, instead of storing pairs of coordinates, to store single coordinates in this compressed fashion as just row times width plus column. And we'll use this representation to solve our problem. So we want to convert this original array into an m by n or n by m, whatever the order is. So if the lengths do not match, because of course if we have m by n, then m times n is the number of elements, we have to return an empty array. Otherwise, we have to convert this 1D array into a 2D array. So this will be a 2D array, which we'll do using a 2D list comprehension. Of course, well, 2D list comprehension, this is just a list comprehension within a list comprehension, nothing special here. So for row in range m, so we'll be creating row by row, we'll be creating everything for all the columns in range n, and now what we have to just add is the value of the element. And the value is the appropriate value in the original array, and that value is at position, as we mentioned, row times width plus column. And of course, as you can see, at first r is equal to 0, so c will be 0, 1, 2, 3, and so on up until n. Then again, row will be equal to 1, so everything will have value n plus c. c going from 0, 1, 2, and so on. So this is exactly the transformation here. It's very useful to be very fluent with that transformation since it's simple, but useful and powerful.